Nice there.
Mark, are you able to hear
Hey,
me?
how are you?
Yeah.
All right. I'm just filling in.
So when are you coming in next week? Are you going to be in person or doing a remote demo?
Uh, are you in Plano?
Yeah, I am in play now.
Yeah, I'm coming Monday. I'll be there mid-afternoon, and I'm leaving Thursday morning.
Okay.
So the our team leadership team offsite is Tuesday and Wednesday. And we may be able to meet up either Monday after um mm, after I get situated, or maybe Wednesday.
Sounds good.
Yeah,
Yeah.
I left. I could have left Wednesday night. It's just I would have been in Seattle super late, and I figured I'm going to leave the evening in case I want to meet up with anyone.
Yeah, it's a good idea, right? Yeah. It'll be
Mm.
very
I mean,
hectic
I
out
want to
there.
see. I
But you
want to
don't know
see.
what happens at the airport these days. So
I want to look around the Plano campus too, just to see what it's like. Okay, so I need to share this. Manu, how are
Good
you
morning,
doing?
guys.
no,
All right.
I have to drop off in 30 minutes, but I thought I would say hi and join you guys.
All right. I put you in our attendees.
Oh, thank you.
So topics. Let me share the meeting minutes. Mm, and doc. It's coming along nicely. I did a little bit of reformatting on it to make it fit in fewer pages. I added the actors and services. Um, and then I had to make the font a little smaller on the tables so they would fit on a page each. And then we still have a bunch of to-dos. We have the thread model effectively finished. But it would be worth to give it another look. Okay. Oh, it's 4 minutes after, so might as well get started. So let's quick review of the section I added because I figured I never introduced any of the actors or terms. But if you can simply read this along and let me know if it's okay to accept this paragraph or make some edits. Hi, Hank.
Hello, my friend. Sorry for being absent last week. Busy,
Oh,
busy.
well, that just means more review work for you.
Yeah,
Okay.
unfortunately, that is true.
All right, so we are actually in the finishing stages of this document. I believe
Mhm.
just a few more additions and it will be ready to get published. Then we need to figure out if we need to turn it to ASCII R or to another IETF draft. Um, we decided, well, I mean, Whimsy is not going to have the bandwidth to uh, consider it in the Shenzhen timeframe, but I'm not going to Shenzhen anyway. But maybe something we can have a discussion around in Vienna, where I plan to be there. But let's see. So let's just do a quick recap here, and then I also want to show a pull request from Joe Salloway in Whimsy that talks about bootstrapping credentials for workloads. So when you joined, Hank, we were just looking through this paragraph. If there's anything I should change about it before I accept it, then we can just move on, make it quick.
Actors and services. That one is the new one. Yeah. So the workload obviously does not conflict with Whimsy. Workload owner, interesting, but okay. Control plane is an interesting workload owner. That is not wrong, but also not the intuitive first reply. Entity that owns workload and decides which identity it is to have. So why is that the control plane?
Yeah,
Well, I do not know if
yeah,
I want it.
I have an issue with that too, Mark, because we had discussed, and I may be confused with other things, but the the identity of the workload owner and the authentication of the workload owner to other actors in this list, we said was important. So if it's the
Yes.
control plane, it feels like it's the all-knowing,
Yeah, it's too
all-seeing.
amorphous. So I
Right.
took it out.
Yeah.
That's
Okay.
better.
Yeah, the owner decides which identity it is to have. Okay, fine.
Yeah.
That's the controlling unit or entity, whatever. A key
Yeah.
store, a Harvard security module. Oh, that's very specific immediately. Or equivalent trusted service. That is very nice formulation. I love the or equivalent stuff, which is something I always write. Whose job is to generate and keep certain cryptographic keys safe from disclosure and tampering by allowing certain operations to be performed using these keys. Yeah, so a HSM, just to phrase it a little bit differently, can contain secrets that will never be exposed, but you can operate on. That's also a feature of an HSM, but that is not what we want here, right? We want the key store to give us the keys always. So it's
No,
not
not
hiding.
always. There are some keys that will generate but will not release.
I see.
So you
Okay,
can
so
ask
that's a
it, for
full.
instance, you can ask it to generate a key pair, but it will never yield a plain text
Private key.
private key.
Yeah.
It may release the wrapped version of it.
Yeah, or it gives you a signature, but you can
Correct.
do operations with it, but never
It can also do that. Yes.
or proof of possession. Okay, good. So I think that is pretty straightforward. Let me scroll back to the document because I was looking up what HSM is used. Credential authority. Oh, that's interesting. A trusted issuer of workload credentials. So it's a kind of CA.
Yeah.
Okay. Why don't? Yeah, well, it's exactly a CA.
Well,
But
because CA
since
is a
it's
certificate authority, and in our case, they may also be WITs that are not certificates.
I see. Then we have to define credential.
We do in as part of Whimsy definitions. Sorry,
And then
TWI. TWI defines all these terms.
okay, wonderful. Then verifier, a trusted instance of the RATs. Oh, interesting. Verifier service. Okay. I would just write a trusted instance of a RATs verifier.
A
RATs verifier used in remote attestation of workloads and remove the service. Obviously, it typically should be a service. It could be a co-located function. You never really know. You're constraining yourself by saying service, and in 5 years you're like, oh, why did I write service? And this is better. That's easy. Okay, done. Good, acceptable.
Okay, excellent. I'm gonna close that. So everything else that is not in green has been reviewed already. And again, Hank, at any point in time, feel free to take a look, make comments. Nothing is cast in stone. So last time we discovered that a workload owner and the key store must have a mutually authenticated secure channel. Because the threat model informed that there could be really bad security vulnerabilities creeping in if they aren't. So that's why this was added. So with your permission, I'll accept step
So
3.
this implies that the workload owner is a actual piece of code that sits between the key store and the workload.
Not between. the workload at this point in time does not. So again, so let's go back to this diagram. So
Yeah.
if you'll see that the workload in the provisioning phase is not really even involved until the very last step when it's given some stuff. Okay,
Yeah.
so it's really, giving the stuff to the workload is actually part of acquisition. So it's sort of here for completeness. But so the workload owner will create the workload identity and will pre-compute the anticipated attestation results that would give that identity to the workload, all without starting the
Yeah.
workload. This is just right. And then it needs to work with the key store. And this is the secure channel gets established here. And then it needs to basically give the key store the anticipated attestation results. And it needs to get back from the key store some stuff. And turns out that when we did the threat model, we basically analyzed every possible threat. That if the key store talks to the rogue workload owner, or if the workload owner talks to the wrong key store, really bad things can result.
So it's mutual authentication. That was my question,
Yes.
but you already answered my question because a secure channel always includes mutual authentication. So if you have half-side mutual authentication, you have to say that out loud and say it's like half a secure channel. But okay, wonderful. Makes sense to me. Yeah, and in this case, it makes sense because the keys go to the workload owner actually, and everything in the end is then prepped and then is moved to the workload, to the executing workload. Okay.
Yeah. Right. So that's why this step 3 was added. So I'll accept that because this, again, we decided
Okay.
last
Yeah.
time it was necessary. And then I
Thank
had
you.
to renumber a bunch of things down here. Anyway, so
Can you go back to the definition of workload owner for a sec? Workload owner, entity that owns the workload. Is it always the case that it owns the workload, or is it really that it's an identity authority? It's the authority that names the workload. The kind of
well,
mirroring the credential authority
the
that.
reason we called it an owner, workload owner, is somebody who wants the workload to run,
Okay.
right? And I mean, I
Yeah.
Yeah,
don't
but
know
it
who.
also has technical means to initiate protocol actions to do
Okay.
that.
Okay. Good. That's
Yeah,
fine.
like
I just, yeah, that's fine.
Now, look, if you're going to go completely legalistic about it, it may be that I actually don't own the workload. It may be some licensed piece
No,
of
I
software.
didn't mean to go. I didn't mean to go legal about this. I was just because we talked about identity. It's the entity that assigns identity to the workload, and
Correct.
then we have an entity that manages that has authority over the credentialing to the workload. So I was wondering if there was a parallel there, identity authority versus
Yeah.
credential
I
authority.
I do
But
not mind renaming it. We just need to do a global rename. The term is used all over the place.
this is fine. Let's keep it that way.
Okay. So I added here under step 6 something that again we discussed last week, that the CSK, this is the credential signing key pair, is stored in case the workload owner might subsequently ask the credential to be renewed without changing the signing key. That's why it's there, right? So it could have been possible to just store the wrapped CSK and discard the private CSK, right? But we're keeping it. This is the reason why. And then for the credential to be renewed, a new credential signing request needs to be issued, and that has to be signed by the private key. And that's only the key store can do that. All right. So again, unless there are objections, I will just accept this change.
seems good. Yeah.
Okay. Next, step 11 was added. And the credential authority here validates the CSR that the CSR has originated from the appropriate workload owner and the key store. Again, this is threat model informed, but the idea was that if the credential authority takes the CSR from anyone, right? So I send it to CSR and say, if somebody presents this private key to you, know that this is my payroll application. And if that can be fabricated, then the workload of attackers choosing could then choose to impersonate that workload. And the way to get around that is to know, for the credential authority to know who is requesting that credential, that it's not some rogue party. And we can go over the details later because the threat model actually talks about it. So you can bookmark when we go to threat model for provisioning, it's step 11. So again, unless there are objections, I'll accept it so we can move on. Okay, now acquisition phase, really no changes to it. I've changed just a little bit, cleaned it up but just cosmetically. There's no substantial change here. All right, we're gonna come back to this, all the highlighted stuff. These are the to-dos. I just want to scroll down to the threat model. So again, the threat model has been cleaned up a little bit. If you were see like last week's, it's just I merged these two cells because they're basically talking about how you should generate the identity on the workload and the attestation results as a pair. So it's better to just talk about the mitigation as something that applies to both steps. So there's just a little bit of cleanup. So step 3 was introduced for mutual authentication, and this is basically implementing standard practices for securing communications between two entities, mutual authentication, data and transit protection. That's just standard fare. And then number 4 basically says all of these threats between the workload owner and the key store, they actually mitigate it if you do what step 3 suggests. But it talks about every one of the threats. And then going down to 11, this is where I said put a pin in it. I basically said that the credential authority, actually should say that, I don't really abbreviate them. Authority must do either or both of the following. Authenticate the workload owner and establish a secure channel with it before trusting the CSR. Again, the secure channel is so that somebody doesn't inject their own CSR into the mix. Certainly need integrity, meaning may not need confidentiality. You don't need integrity. And then you can authenticate the key store and basically saying it's the key store that issued the CSR. And hopefully, if we trust the key store, depending on a particular situation, somebody may want to go a couple of different ways on this. So I want it to be somewhat generic in how I recommend it.
Mm-hmm.
But please, feel free to suggest a better wording.
Better wording is always hard.
Yes. And again, this will go up for broader review, so there'll be more pairs of eyes on it.
That is great.
At this point in time, what I want to do more than anything is I want to wrap up and basically say, look, we've done, this is our version, whatever, 1. And then, people can throw rocks at it, and that's fine.
Makes sense to me.
Okay.
Especially if we are not targeting Shenzhen and have to transform it into a draft anyways. If we would have a draft in for IETF 125, I could do a hot RFC on it, which is like this 3-minute, 1 slide. Hey, by the way, and that is the very beginning of the IETF on Sunday, I think. But that requires a draft. So I don't know if we have the time to do that. But it can be the weekend before, right? So it's hot RFC. It can be like smoldering hot out of the oven. I don't care. They don't care, right?
So if Rats wants to do it, I'm more than happy to. It's just somebody needs to go and do the grunt work of ASCII art and conversion. I can tell you, I will not have the time. I have some work travel coming up.
Now, Mark, hot RFC is just an open stage where people can come in for 3 or 4 minutes and then present in any format, just slides and stuff.
But this is Shenzhen, right?
Yes,
Yeah.
but
Yeah.
you can submit the slides just 24 hours before the event,
Okay.
and it's
I'm
completely
I'm more than
informal.
happy to do it. It's just somebody else will need to do the actual work. That's what I'm saying. I'm not registered
Yeah.
for Shenzhen. I'm not going there. I will watch
Yeah.
recordings.
Yeah, I think Hank was volunteering to just
Yeah,
throw a
please.
few
No,
slides
please.
up.
That would be
I will.
fantastic.
So we have an existing ASCII art that is at least close to the ASCII art, to the diagrams we already have. So I
Yeah.
can go from not from zero, but from something. Everything else is just tables, text, and sections.
Yeah. I
That's
mean,
not my
these are
typical.
complicated tables.
Yeah,
Now.
I have to admit that, and maybe they are not super readable, but in ASCII then, but it's a 0, 0 again, or it's a 0, 1 of the existing. We have to decide that. I will have some time tomorrow, actually,
Mhm.
and I can ponder that. And when you all wake up here in the US, I might have questions.
Yeah.
Yeah.
I mean, I'm around. It's just I'm not engaged in Shenzhen at all. But no, if you
Yeah,
want to
it's
do
just
this,
it
if you want to do this, Hank, that would be, more pairs of eyes. It's always good.
yes,
So yeah.
and I
Okay.
haven't had the time in the last 14 days. So that first TCG and then something, and so yeah, so I will have to this okay. I will look at this tomorrow because I arrived super early to get a meeting at 10, which is cancelled. So I now get
Great.
up at 4 a.m. in the morning and get into a hotel which I can't check into and don't have a meeting. So I'm super happy about that, and then I can find time maybe to do this.
Okay, that would be lovely. Okay, so so that completes the threat model. We still need to talk over a few things here and to do. I just want to draw your
Hmm.
attention to something before we do that. So this is the Whimsy pull request 114. So again, you can see this under the Whimsy working group. So Joe Salloway, he's in Seattle here. So he and I met a few weeks ago, and I basically told
Good.
him that the architecture, the Whimsy architecture, needs to separate credential provisioning from credential use. And he agreed with me, and then he did this write-up. So in the status, or sorry, in the agenda email, you have this URL. I can copy paste it here. So this is the pull request 114. This is under Whimsy. This means they are aligned with us, certainly thinking about that Whimsy should be primarily around the usage of credentials and less so about how the credentials come about, but they still want to say something. So you can read, so here's the files changed. So all the write-up is here. We'll probably not go over it here.
Well, I can
Here.
do a review on GitHub also tomorrow. I
Yeah.
can put it on the list.
Okay. So please
So
do.
this
This
is
is
pull
this is good.
119, yeah? 119. No, which pull request is this? 114. Okay.
114. You can
No,
see it in the
also,
chat. I put it down there.
yeah, but I don't see the pull request. It is already merged. There's nothing to review.
Didn't he say
It is
that?
already merged.
Oh, it merged. Well, if it merged, then it still kept this Provident typo. And see, I I had additional
Yeah,
comments, but yeah,
somebody didn't
please.
pay attention.
Maybe he
That is
wasn't. Yeah.
unfortunate. Maybe. Let me check the convo real quick. Maybe it was just unfortunate timing. It was merged yesterday, and from the
No,
timeline.
my comments were several days ago.
Yeah,
Certainly not.
you precede them significantly. Reworking this section to make it clearer. Okay, there was something accepted and some things weren't accepted. So this were not all your changes, but some. Oh, yeah, but you made it as a comment, not as a suggestion. The suggestions cannot just be click accepted. They have to create your own change. It's
Oh.
always better to have typos with the suggested change, with the suggested change feature, than people just click commit and it's done. I can see why this did not happen because people are lazy. But
Right.
it happened to me too, so I'm not
But
blaming anyone here.
it can be versioned further. So I just
Yeah,
wanted
yeah,
to draw
yeah.
your attention to this. Please take a look. But
Okay.
this is definitely moving Spiffy in the right direction. All right.
Okay.
So coming back to our try profile, let's go in the order of to-dos, and this is why I highlight them in yellow so they're easier to spot. So under the discussion, I wanted to talk about this one first because I think it's short and I know what I'm talking about here. So you can see that the acquisition step still requires some network traffic. And if you have a workload that is maybe super short-lived, may keep reusing the same credential, it is possible using this confidential computing primitive called sealing to the platform to basically for workload to seal something such that next time it launches, it can unseal it for itself without going outside. So the way this works is there is usually an ABI that says, give me the key material for myself. I'm just a little hesitant with this simply because we need to convince ourselves that if the same code starts but in a different configuration, that it would not be able to derive the key for itself, such that it could then, running in insecure configuration, obtain a credential of a workload that was attested as running in a secure configuration. So that's a potential vulnerability. And Sudhir, you and I on your prototype, we may want to talk later about just prototyping that again as a just to see is it what precautions do you need to take? So, for instance, in the key derivation logic, when you call that ABI, if the workload is coded to always include its configuration in the key derivation, then starting with the wrong configuration would basically cause it to derive a different key and not be able to unseal the workload. But it needs to be very carefully coded if you're going to do that. So I do not know. Given that, should we say something about it, or should we just avoid the red herring?
Well, I actually think we should say something about it because, and it's not the first time that we talk about sealing, and I do believe the sealing primitive should be something that the CCC is trying to promote systematically because it's not available on all confidential computing things. So I think we should mention it and keep pushing for it.
Okay. So what I'm going to do is,
But the
Henk, I know you're
actual
going to be working on it
implementation,
tomorrow.
Mark, is probably much bigger than any custom thing that we build, right? I would rather, because to me, if a key is compromised, then all the ceremonies and orchestration we went through is useless, right?
No.
Workload
Well,
can
if the key
pretend
is
to be anything else.
if the key is compromised, if your signing key is compromised, yeah, everything's out the window. That has nothing to do with this particular section. This section has to do with I have my signing key. I'm going to seal it. So if I don't know, power goes out and I need to start up again, I would be able to continue using the credential without incurring the network latency off and the additional load on the verifier. So I believe it's possible, but I'm I have too many scars from security incidents to take anything lightly.
Well, we know it's possible. I mean, for instance, the SGX implementation is pretty tight. So you cannot, if you've changed one bit in the SGX, enclave, it simply won't be able to retrieve anything that was sealed.
Yeah, but we're talking about configuration here, not code.
No, I understand. I understand. We embed configuration in the code, but in any case, the Sudhar, I wanted to react to what you were saying because the name of the game here is not. Of course, there's if anything breaks in the chain, right? Then everything is broken. But oops, sorry, I'm going to drop off. But the important thing is the minimization of the attack surface. So every mechanism, and if we want to increase performance, right, it's this balance between the two. So yes, potentially this is another mechanism that can break, but it doesn't mean that all the efforts that we've done so far are not worthwhile.
Okay. So I'm going to write it up. So the next one is credential rotation, which again, something I could write up because that one's actually easier. Simply says well, my credential is issued, it's given a certain length of time, but I could extend it. And to extend it, I basically, there needs to be a process that I do not know if the workload can do it. But effectively talking to the credential authority and basically say, hey, renew this credential for me. It should not require much other than the knowledge of the CSK, because that's how you redo the CSR. The only question there is who's going to be doing it? Is it going to be the workload owner or is it going to be the workload itself?
Ha. That depends on the scenario, maybe. Is it really fixed?
Sorry? Is what?
That might depend on the application scenario. Is that really a rule that you can fix on the entity? Sorry for asking this complicated question. Maybe
I
it's
don't
not.
understand. Well, I mean, I understand the question. Maybe if I understand the question,
Yeah,
I can answer.
you're asking, is this a duty of the owner or is it a duty of the workload? And my question was, can you would the answer apply to all scenarios? And my assumption is no. In some scenarios, it might actually be the workload that is in charge, but I'm not entirely sure. So I would tend towards owner,
Well,
but I can
so the
see
private
workload.
CSK lives in two places. It lives inside the
Yeah.
workload once it attested and was able to get the credential key, and it lives inside the HSM. And in order to extend the credential, you effectively need to regenerate the CSR. For the CSR, you need the private signing key, and uh, and then you go to the credential authority. So the workload owner could do this and basically say, extend this credential for me, and then it's just another call into the key store saying, give me another CSI around this key, and then go send that over to the CA. The workload could also do this, but then the only thing is the workload is one of 1,000 potentially, right? So they all should not be trying to renew their credential. Well,
Mm.
they kind of can, right? So I mean, this is where the paragraph could talk about this, basically saying, look, if you need to extend the credential, you have a couple of ways of doing it. The workload owner could do it, or the workload could do it. We could probably recommend that the workload not do it because it doesn't know how many other instances of itself exist. And you don't want to renew the credential for just for yourself.
So what's your predicted answer? What do you think is the
My
answer?
predicted answer is the workload. What the workload owner should do it.
Yeah, that is what I was leaning towards too. I also, but again, we might artificially constrain ourselves here. But let's go with the owner for now, and we can revise it in a later version if we think it's too narrow. I think also that's not a bad thing.
Okay, so I added that comment. Those will be mine to do. All right, let's go through the rest of them real quick in the last half an hour, so we at least know. And again, if we're gonna go the hot RFC route, Hank, we don't necessarily need to answer all of them. We may leave some as future work. But I just wanted to make sure we at least thought about everything, even if we don't address it. So there's something about the supply chain concerns about the CWK access policy and verifiers. I don't know who wrote this, so I would have to decode what is meant. So CWK access policy, let's just, first of all, let's refresh our memory why that is. The CWK is the credential, it's a CSK wrapping key. Right? It has a one-to-one correspondence with the CSK, and so let's go back. It's CWK is generated right here. Okay, so here we're generating the CWK, and we set the CWK access policy to attestation results. So this means that in order to be able to do anything with the CWK, which means wrapping the CSK, uh, you know, you need to produce the attestation results. So you need to be the workload that's expected to be running. And the data access policy never changes. So if you upgrade your workload to the next version and your attestation results changed, this means you need a new CWK. And again, this is threat model informed. The threat is if you change the access policy, then the wrong workload will be able to obtain the signing key and bad things happen. So, but there is something about supply chain, like some, and that again, we should note who said what. So I no longer remember. Maybe we'll just delete it and make a comment here saying, if you made this comment,
Is there a concern around the evidence or the attestation results containing things related to supply chain? Like,
I mean, again, your
incognito?
guess is as good as mine, and this is where I am inclined to basically say we're just deleting it with the to do. But again, I'm not deleting it from the text yet. I'm basically saying, look, if you talked about it and you see this, please chime up. And Siddharth, if you think you can reverse engineer what was meant and write up this paragraph, please go ahead. But I want to
I
make
don't
sure that every to
like.
do is addressed. And here I don't know exactly what to do immediately. Like supply chain concerns for verifiers. Like I mean I don't know. All right. This one, the mapping of evidence to attestation results to allow flexibility without having to graph that as a workflow. So, Henk, this one I remember. So attestation results, or sort of the evidence for workload, is a lot of things. It's all the properties of the chip, and it's the properties of the code itself, right? So, but evidence may
Yeah.
change within a certain range without making the workload less secure. So, like the
Yes.
hardware
In
operator may
runtime.
choose to upgrade firmware, whatever. And so,
Yeah.
this is actually I'm going to be presenting in April to the attestation SIG at the consortium, basically explaining that we need to have some solution for the fact that different parts of evidence are controlled by different entities, and these things will change, and we need to be able to produce, in some cases, the same attestation results for a variety of evidences, right? So all of that, I don't have exact solutions yet, but the fact remains that if your CSP goes and updates the firmware, but you haven't changed your workload at all, there may be even a missing notification. All of a sudden, things start breaking, right? And we can talk about, I think this needs to be. This is not just for this case. This is for so many different cases that we need some flexibility. So I'm almost think that there needs to be maybe under rats actually. Hey, maybe let's brainstorm this. Like, I would like to reference an external document that talks about, how to not break things when things legitimately change.
Yes, so that's a policy versus reference values endorsement question. So the scope of change, allowed change, is a composite of what you think of as a reference value, like the intended state of something, and the endorsement, like, hey, this hardware is cool because it can do the ceiling thing you want, right? And
Yeah.
in its HSM, and thereby it's appropriate hardware. So that's an endorsement. And now policy can tell you, yeah, but this one had a problem and thereby is not allowed. So there is a SVN on this CPU, and this SVN range is illegit. not legit anymore because there was a problem with the seed operation. I don't know. I'm making things up. So that can go into a certain new quorum, for example, which is endorsement and reference value, which then removes some of the reference value. For example, version that is represented as SVN, or it could be some other thing. So I think changes over time that are the things you create evidence about or are endorsing, like the hardware, are not a problem as long as you have a good mechanism that provides evidence over time and keeps your endorsements updated over time in the verifier. That's the really hard part here. So runtime integrity measurements, it's called in TCG, which is I want to say runtime evidence generation, and also keeping your endorsements and reference values up to date all the time. With deterministic verifier behavior is the other challenge. If that is both in place, this is covered. So I would
So
say all of this is just that stuff.
let me then ask you perhaps to write this paragraph up, because this is much closer to rats, and I do not want this to be a one-off for this particular um, um, document. This is far beyond the current document. Do you see what I mean? It's like it needs to be a reference to something outside of this doc.
Yeah, runtime integrity is not the hot topic at the IETF that you would expect it to be. There is upcoming runtime integrity stuff with Yang, like for the management stuff of network equipment.
Yeah.
That is an individual ID that has no normative standing. And also will probably merge with another draft that is doing the initial measurement and then the runtime and composite somehow. I don't know from the top of my head that we have a good runtime integrity measurement document. To be fair.
So, well, it needs it, but you see that this is a very, very key part of making things deployable, which is the thing that is very, very near to my heart. Because if we're like, it's one thing to do a research project for confidential computing, and it's quite another to keep it operational.
Yes, yeah. Then research is fine. I love research. Things without research mostly don't go well.
Yeah.
But we're talking about standardization here. This is either more established or more obvious. I want to call it that.
Right. So this is where I want to maybe be part of the effort. It's just what I'm saying is it's kind of a to-do. It's kind of something that rats needs to figure out. Rats and the attestation SIG. This is why I'm going to be talking to the attestation SIG, because I carry more weight inside the consortium. But maybe you and I can collaborate on how to bring this to rats. But it shouldn't be part of this doc because it's not going to be solved here. This can be mentioned here.
Okay, I would say talking about this, or at least asking Thomas Fossati and Google guy, Microsoft guy, who was it? Greg Costa? Yeah. I think both of them, and asking about, hey, by the way, what's the current status of runtime integrity measurement? We need this like a continuous process when hardware changes below my workload. How do we do this? And then there might be crickets or some pointers to future work. I think that is the CCC way first point of contact. There's a new NVIDIA guy next to Greg and Thomas I forgot the name. I think they rotate chair duty for the attestation SIG. As one of the attestation SIG chairs.
Yeah. So Greg Costa was the one who told me to come to the attestation SIG. This is going to be April 21st to talk about it. So I know he's very keen to discuss it, which means that he doesn't have a solution in mind just yet.
Oh, I see. Okay, good point.
So
Then
that's
the
why I'm
whole
basically saying
attestation
we can
should be not
basically
valid.
say
Yeah.
I can okay
Yeah.
I can write this up as well and basically refer to future work, use the term runtime integrity measurements to say that. Okay. Um, let's move on. So talk about partitioning, sharding credentials across regions and availability zones. This is okay. This is Siddhartha, what you said. Like this is like, break one, break all. But we could at least limit the compromise, basically saying, look, you should probably, if your workloads run in three availability zones in the same region, you should probably still give them different credential keys.
Yeah.
Right. So if one HSM and one availability zone breaks, at least you contained your breach to that one, some kind of sharding mechanism. And again, this can be written up without too much difficulty. I could do that.
So one question I have, right? I don't know, this may be ignorance. So if we create a confidential VM, multiple confidential VM, whether it's an Azure or Google, the attestation result and the firmware and hardware properties,
Hmm.
they should be different, right? Like for each confidential VM that we create, right?
What do you mean? What should be different again?
The measurements, the firmware properties, or the hardware properties that's part of the attestation results. Um, they have to
Uh,
be unique to that confidential VM, right?
mm, the hardware is going to be like the evidence for the hardware is going to be similar. Um, uh,
Like what would distinguish, like if I have multiple workloads representing different business applications running within confidential VM environment, right? How can I just rely on the firmware and hardware? Because those are just provisioned to run my workload and doesn't have any context of my application.
But they
Am I
provide the
making any sense?
confidentiality features. Maybe you're not following entirely. So the hardware typically is the thing that provides all the assurances for confidentiality, like in confidential computing. So why are not why wouldn't firmware and hardware measurements or endorsements not be enough for that?
I could
I mean, you
provision
can.
like 5 confidential VMs, right? And on 2 VMs, I run workload A, and 3 VMs, I run workload B, right? But if
Yeah.
the measurements that come across for all 5 workloads are the same,
They will
then
not be if they have different configurations or different code. However, if they run the same code in the same configuration, their evidence should be the same.
but is the workload hash or anything part of the attestation, or is it
Well,
just limited to the firmware and
so there are three parts. Broadly speaking, three parts. There is the hardware. Hardware for that include the firmware, like it's your CPU, your GPU, stuff on which the code runs. And then there is the code itself, and that's the logic. And then there is the security sensitive config, so your trust roots and whatnot. So there are three parts, and the second two parts are going to be the same when you run VMs. But if I run the same VM but with two different configurations, then they're different workloads. And if it's the same VM image but the exact same configuration, it's the same workload.
when you say configuration, that's what I want to make sure,
Like
right?
trust roots, like security sensitive config.
Is that part of the attestation, right? That
Yeah,
it has.
it has to be. It has to be. Yeah, this is the workload. This is the under the workload governance pattern and the GRC SIG. This is where all of that is covered.
Okay.
So basically, the mantra is this: if you run good code with bad configuration, it'll do bad things. Like running good code is not enough.
Yeah, whatever we use to assert the workload identity,
Correct,
to make
correct.
sure.
Whatever the workload chooses to include in its attestation, if it does not include its security sensitive configuration, then you got a security bug.
Okay, yeah, we can talk more this afternoon.
And by the way, the workload does not control what code it runs. That's controlled by whoever launches the workload. The workload controls the implementation of the workload controls whether it's going to include its configuration in attestation or not. And if workload is poorly implemented and manages to like not put the right configuration into attestation, it's gonna break.
Okay.
Yeah. Okay. We have one last to do, and that's the crypto period. It's almost something I can include somewhere by reference, basically add it to the references and basically say, consider crypto period as an alternative to key rotation, and it could be done as part of the credential rotation. In fact, you know what I'm going to do? I'm going to move this from here to here. That I can do. Yeah, I can do that when writing up credential rotation. All right. So Hank, when did you say you can get down to ASCII-fying this?
I can skim it tomorrow. I have time tomorrow actually. The IETF deadline is behind me, and I have to fill a
Then
morning, which
let me finish all these write-ups today, so that by tomorrow you
yeah.
can pick it up and it'll have all the bits, and I'll keep the change tracking on, so you know exactly what I wrote.
Okay.
All right. Okay, I think with that we're done for today. There's nothing else. Nice, sweet 13 pages.
Yeah, it's coming along good. Thank you
Yeah.
for all your
Well,
effort.
it's one of my things I wanted personally. I wanted done by end of March, and I think we're quite well on our way. All right, Hank, thank you for attending today, and
Yeah.
I will see you all next week.
Thank you.
All right, take care.
Sounds good.
Okay, bye-bye.
Bye bye.